Okay, so in this case, we've got x equals at squared and y equals 2at. Right now, with parametric equations, we should expect the parameter to be in terms of t and theta. Those are the letters they're usually in, right? So don't get confused or put off when suddenly there's a letter a there as well. Okay, usually in the exam it'll state and it'll be quite clear what they mean by a, and quite simply a is just a constant in this case, right? So in a way, just ignore it, right? It's got nothing to do with the actual function, okay? It's just a constant multiplied by t squared here, okay? So we'll include it in our answer, but don't worry about it. You know, we've got to think here of this as x in terms of t, so we'll differentiate that, so we get dx by dt, okay? And of course, when you differentiate the t squared, the 2 comes down, comes and times in front, and you've got the a there, okay, as a constant. And then of course the power becomes 1, okay, because you reduce that by 1. Same here, we've got y in terms of t, so dy dt will be, well, because it's just a t, it'll just become 1 when you differentiate it, so you've got 2a there. Okay, so remember then, it's useful to flip this to write dt by dx. Okay, so flip that, it'll become 1 over 2at. Okay, and then using the chain rule, well, we have dy by dx. So remember, dy is on top, so dy by dt times then dx on bottom, so dt by dx. Okay, so the chain rule works there, and you simply multiply those two results that we've got. So we've got 2a there for dy by dt, and dt by dx is 1 over 2at. Okay, and you have that now, 2a times 1 over 2at. If you want, if you find it easier, you can then write it like this. But what you'll notice is that you've got 2a on top, 2a on bottom. They'll actually cancel each other out. Okay, so you'll end up with then 1 over t. Okay, and sometimes a question will ask, they'll say, okay, show that dy dx is independent of a. Okay, so and if you look at the value of dy dx here, it doesn't matter what a is, doesn't it? Because they cancelled. So we've actually shown that there. If they asked us that, we've shown that it's independent of a, and there's our value for dy dx.